Determine the left-sided limit and the right-sided limit and the two-sided limit as x approaches pi over 2 of cosine of x divided by sine of x minus 1. Each of these involves the limit as x approaches pi over 2 of cosine of x divided by sine of x minus 1. The first thing to do is try plugging a pi over 2 in for each of the x's. That'll give a cosine of pi over 2 divided by a sine of pi over 2 minus 1. The cosine of pi over 2 is a 0, sine of pi over 2 is a 1 minus 1, and 1 minus 1 is 0, given the 0 over 0 indeterminate form. We will have to rework this. Neither trig function is squared. We do not have a Pythagorean trig identity to use. Neither trig function is of 2x. We do not have a double angle identity to use. But we do have a trig combination, a sine or cosine added or subtracted together with a 1. It's happening in the denominator here. And we can therefore make use of a trig conjugate. The original limit can now be multiplied by the trig conjugate. The conjugate of the trig combination is the same two terms, but opposite sign between them, so there'll be sine of x plus 1. And we will put it over itself, a form of 1, so that when we multiply, we do not change the value, just the look. In the numerator, those are not trig conjugates. They will not multiply. We do not want to distribute the cosine in. We will keep it factored out. In the denominator, those are trig conjugates. We will FOIL it first. Sine of x times sine of x will be sine squared of x. Outside, sine of x times a positive 1 will be a positive sine of x. Inside, negative 1 times sine of x will be a negative sine of x. And then last, a negative 1 times a positive 1 will be a negative 1. The outside and inside terms are equal value opposite sign, and they will cancel. This gives the limit as x approaches pi over 2 in the numerator. We will keep it factored in the denominator. We have sine squared of x minus 1. That has a Pythagorean trig identity. The original identity is sine squared of x plus cosine squared of x equals 1. We can subtract 1 from both sides, which will move it over there with the sine squared of x, and subtract cosine squared of x from both sides, which means it'll move over to the right side and also be negative. They interchanged with each other. Sine squared of x minus 1 is equal to negative cosine squared of x, so we can replace that in our denominator. So we have the numerator left factored. In the denominator, it can be replaced with a negative cosine squared of x. We still have the 0 over 0 indeterminate form because the cosine of pi over 2 is a 0. But we can cancel the cosine in the numerator with one of them in the denominator to remove the 0 over 0 indeterminate form. What's left is a sine of x plus 1 divided by a negative cosine of x. We can now try plugging a pi over 2 in for each of the remaining x's. That'll be sine of pi over 2 plus 1 divided by a negative cosine of pi over 2. Sine of pi over 2 is a 1 plus 1 divided by a negative cosine of pi over 2 is a 0. 1 plus 1 is a 2 over a negative 0. That negative 0 in the denominator is not actually a 0, because x is only approaching pi over 2 here. It does not reach pi over 2. but a limit result of a non-zero number over 0 is equal to either positive infinity or negative infinity, where the sign of the infinity often depends on the side the limit is approaching from. We therefore have to work out each of the one-sided limits separately. We have the left-sided limit indicated by the negative superscript on pi over 2 of the original cosine of x divided by sine of x minus 1, and the right-sided limit indicated by the positive superscript on the pi over 2 of the original cosine of x divided by sine of x minus 1. Let's start with the left-sided limit. We can multiply by the conjugate of the denominator. We'll put it over itself, a form of 1. Just like above, we will not distribute in the non-conjugate set, which is the numerator, but we will FOIL out the conjugate pair, which is in the denominator, to produce sine squared of x minus 1. We have the identity. So we'll leave the numerator alone. And using the identity, we can replace the denominator with negative cosine squared of x, just like above. And the cosine in the numerator can cancel with one of the cosines in the denominator. Leaving sine of x plus 1 divided by a negative cosine of x. X is approaching pi over 2 from the left side here. The left side of pi over 2 is less than pi over 2, but near pi over 2. On the unit circle, less than pi over 2, but near it, we'll put it in the first quadrant. The 0 in the denominator is being created by cosine of pi over 2. But cosine in the first quadrant is positive. So while it's approaching to a 0, it will remain positive the entire time. So cosine of x can be replaced with a positive 0. Pi over 2 can then plug in for all other x's, which will give a sine of pi over 2 plus 1 divided by negative, and the cosine of 0 can be replaced with a positive due to being in the first quadrant, and 0 because it's approaching pi over 2. Sine of pi over 2 is a 1 plus 1 divided by a negative times positive is a negative 0. 1 plus 1 is a 2 over the negative 0. The 2 is a positive. Positive over negative is negative. Non-zero over 0 is an infinity, and there is the result of the left-sided limit. The right-sided limit can be worked out in a similar fashion. We'll multiply by the conjugate over itself. We will not distribute in the numerator since those are not conjugate pairs, but we will FOIL the denominator since those are conjugate pairs. So leaving the numerator alone, the denominator has the Pythagorean trig identity to become negative cosine squared of x, and the cosine in the numerator can cancel with the one of the cosines in the denominator, so that we no longer have the 0 over 0 indeterminate form. What's left is sine of x plus 1 divided by a negative cosine of x. X is approaching pi over 2 from the right side here. The right side of pi over 2 is larger than pi over 2, but near it. And larger than pi over 2, but near it, we'll put it in the second quadrant on the unit circle. In the denominator, the cosine of pi over 2 is a 0, but in the second quadrant, the cosine is a negative number. So while it's approaching a 0, it's remaining negative. And therefore, cosine of x can be replaced with a negative 0, and pi over 2 can be plugged in for all other x's. This will give a sine of pi over 2 plus 1 over a negative, and cosine can be replaced with negative 0 since it's in the second quadrant here as it approaches pi over 2 from the right side. Sine of pi over 2 is a 1 plus 1. A double negative is a positive 0. 1 plus 1 is a 2 over the positive 0. The 2 in the numerator is positive. Positive over positive is positive. Non-zero over 0 is an infinity. And there is the result of the right-sided limit. The two-sided limit depends on the results of the one-sided limits. They do not match. The two-sided limit up here will be does not exist. And there's the results of the three different limits.